Greetings everybody. Let's take a minute to look at this problem here, which I will point out initially takes the form of 0 over 0. The reason I say that is because if this limit is as h goes to 0 and I let h be 0, I'm looking at this and this, which is 0 divided by 0, okay? And I point that out because whenever we encounter that, there's a certain technique that I'm recommending, okay? And that technique is to reduce this function algebraically to something else and then reevaluate the limit once you get it reduced. And that's what this first part is hinting at, okay? To simplify the limit is if to say this limit is the same as doing this much simpler and easier limit. Okay, so let's talk about how to do that. If I was going to algebraically reduce this, which is the function I was given to start with, it would just be a matter of getting a common denominator, subtracting these fractions, and then dividing, okay? But I thought all of that might be a little bit easier to see if we had ordinary fractions that were just numbers, okay? So I'll give you this as an analogy right here. How would we calculate with just pen and paper 2/3 minus 2/5 divided by 4? The way that we would do that is the same for the most part as how I would reduce this one. Okay, so here's the steps. I need to subtract these fractions, and in order to do that I need a common denominator. The common denominator of 2/3 and 2/5 is 3 times 5, which is 15. Okay, so I multiply this fraction by 5 over 5, which is just 1. I'm not changing the number. I'm changing the denominator, but I'm not changing what that number is. And here I multiply by 3 over 3, which is also 1. Okay, and that gets me my common denominator of 15 without changing what any of these numbers actually are. So now I've got 10/15 minus 6/15. Okay, so to subtract, now that I have a common denominator, it's going to be 10 subtract 6 over 15. That turns out to be 4 over 15. Now, in this step, taking 4 over 15 and dividing by 4, the way that we divide fractions is to multiply by the reciprocal. So I want to look at this as 4 over 15, not divided by 4, but 4 over 15 divided by the fraction 4 over 1. Okay? And I look at it like that so that it fits my pattern for dividing fractions. I divide one fraction by another by multiplying by the reciprocal. Okay, so this is not 4 over 15 divided by 4 over 1, it's 4 over 15 times 1 over 4. Okay, then the 4's cancel, I'm left with a 1 over a 15. Okay, so that's the big picture procedure that I'm going to use over here. So to reduce this function that I have to start with in my limit, I'll go about the same sequence of steps. I need to subtract these fractions, okay? And in order to do that, I need a common denominator, which is 5 times 5 plus h. In order to get that common denominator, I multiply this first fraction by 5 over 5, and then this one by 5 plus h over 5 plus h. Okay? In each case, I'm just multiplying the fractions I start with by 1, but I'm doing that in a way that I get my common denominator. Then we have this, okay, which at that point we do have a common denominator, and I can subtract those fractions by taking 10 minus 2 times 5 plus h over that common denominator 5 times 5 plus h. Okay, and when I get here, I'm kind of stuck with it the way that it is. Okay, I want to combine and cancel things. I want to reduce it. I want to simplify it. I mean, after all, those were the instructions, is to reduce or simplify. Those are the words that we use. But as it is here, nothing can be combined or canceled or anything. So I'll distribute that 2 across 5 plus h. If I do that, I get 10, which is already there, minus 2 times 5, which is 10, minus 2 times h, which is 2h. Okay? And that gets me a little bit further because now those 10s will cancel. I get 10 minus 10, that's nothing. It just leaves me with negative 2h on the top. Okay? Now, do you remember in that other problem I said, well, we can divide fractions by multiplying by the reciprocal. So here, if this is where I'm at, I've got negative 2h over 5 times 5 plus h divided by h. I'll see that as divided by h over 1. That's the same as multiplying by the reciprocal, which is 1 over h. From there, the h's cancel, leaving me a negative, a 2, and then on the bottom, a 5 and a 5 times h, or 5 times 5 plus h. Okay, so it reduces to that. Does that agree with this answer I see up here? It doesn't look exactly the same. This says negative 2 over 5h plus 25, but that's just a different form of what I have. I could distribute this 5 in there, and what am I going to get? 5 times 5 is 25. 5 times h is 5h. So that's the same thing, okay? All right, now, if I were to reduce this initial limit to that one, all by algebraically reducing that given function, then this gives me a new way to calculate the initial limit. With this reduced function, I can actually let h be 0, okay? Like, I'll put it in. I won't encounter any problems. With the limit the way it was when I started, I cannot let h be 0. It leads to an impossible calculation with no answer, 0 divided by 0. But now with this reduced one, I can let h be 0. What am I going to get? Negative 2, 5 times 0 on the bottom, which is 0, and then a 25. So I'm going to get a negative 2 over 25, which is negative 2 over 25, which you see here. Okay, so that's another example of a limit form of 0 over 0. What they might all have in common is this algebraic reduction. It might take different forms depending on whether you have roots or whether you can factor, or in this case fractions, but they'll all have that first step in common each time.